Hello, viewers. And in this class, we continue from where we stop in the basic operation of indices. Here, we're going to look at the operations or the applications of the law of indices. We've handled the laws. We'll look at some examples as pertaining to the introduction. And here we're going to see look at more examples or more questions from indices. First of all, let's look at this. Say evaluate we have a 3 raised to power x minus 3 raised to power x minus 1, then all over 3 raised to power 3 times 3 raised to power x minus 3 raised to power 3 plus x minus 1. So evaluate this. Okay, let's see how we can possibly apply the basic principle of indices to resolve these questions. Here, what we are seeing here, this 3 raised to power x minus 1 is the same thing as 3 raised to power x times 3 raised to power minus 1. And if we do this, because the bases are the same, we say x plus, here is minus 1, plus minus is minus, and this will tend to be 3 raised to power x minus 1. So, what we have at the numerator there, here, these questions, this part is the same thing as this. So, similarly, we can say 3 raised to power x minus 1 is the same thing as 3 raised to power x times 3 raised to power minus 1. Then if you look at the denominator here, this part, 3 raised to power 3 plus x minus 1 can also be written as 3 raised to power 3 times 3 raised to power x times 3 raised to power minus 1. So that is what is obtainable. Okay, now we can simply rewrite this. This one will become 3 raised to power x minus 3 raised to power x times 3 raised to power minus 1. Because we have said that the whole of this can also be written as this. So we replace it. Then we also come to the denominator. Here, this is 3 raised to power 3 times 3 raised to power x minus 3. In place of all this, we write it in this form. So this will become 3 raised to power 3 times 3 raised to power x times 3 raised to power minus 1. Okay? Now, having done that, we do some factorization here. If you look at the numerator here, this is common here. So we bring 3 raised to power x out. So here, this will become 3 raised to power x. If we are bringing it out, we put an open bracket there. In place of this place now, we remove it. That means this place is left with 1. Because this time, this will also give us this. So if I am removing 3 raised to power s from here, what will be left with here will be 3 raised to power minus s. So we got minus 3 raised to power minus 1. That's what will be left in that aspect. Then let's look at the denominator carefully. We have a shouting factor here, factor that is common on here and here, which is 3 raised to power 3 times 3 raised to power x. So we bring it out, we factor it out, and this will become 3 raised to power 3 times 3 raised to power x, open bracket. If the whole of this one is totally pulled out from this place, what will be left here is 1, because the whole of this one multiplied by 1 will also give us this. So if we remove this one from here, we'll be left with 3 raised to power minus 1. So minus 3 raised to power minus 1. We'll close our bracket. Here we can see that something can be done. This one they are the same. That means they can divide. They can just be off here. Similarly, here we can say this one can also go off too, and we will be left with 1 over 3 raised to power 3. And 3 raised to the power 3 simply means 3 times 3 times 3. 3 times 3 is 9, 9 times 3 is 27. So here our answer will be 1 all over 27. So these questions now, the answer here is 1 over 27. Okay, that is the question before us. So we are looking at the application of the basic operation of the law of indices, the applications. Okay, now having done that, let's look at this question. We have this question. Let me put it here. Say if we have if 8 raised to the power x over 2, 8 raised to the power x over 2 is equal to 2 raised to the power 3 over 8 times 4 raised to the power 3 over 4. Okay, this is the question before us. Say find find s square minus or plus 2x. Okay, so we should find x square plus 2x. Okay, now this question, how do we go about it? Simple. We can operate it and see how much we can get out of it. Right here, we see that 4 raised to the power 3 over 4. Okay, here we say we should find s squared plus 2s plus 2s. Here there is no s squared here. What we need to do, the value of x, we square it plus 2 times that. So that means we have to solve this to obtain the value of x. By doing like 8 here and the base here, they are not the same. The base here, they are not what? They are not same. So what you need to do is, first and foremost, you have to look at how to make them the same. And look at the operation side here on the right hand side. And we know that this indices is a form of equation. A form of equation. Okay. Here, it can be written as 2 raised to the power 3. That is 8. 2 times 2 times 2. That is the common prime number that can divide 8 is 2. Then here we have x over 2 before. Okay. So here it's already in 2. So here is 2 raised to the power 3 over 8 times. Here we express it as the prime number in index form, which is 2 raised to the power 2 times 3 over 4. 2 raised to the power 2 times 3 over 4. So here on the left hand side, which is 2 raised to the power 3 times x, that will give us 3x over 2. Here 2, here 1, 2 in 4 is 2. Here we quickly, because this base here, they are the same, and there's multiplication sign here, we have to do use the law of indices. So here will be 2 raised to the power 3 over 8 plus 3 over 2. So quickly, let's look at this fraction here. This is a fraction. Let's do the operation to this fraction. Okay. Here the LCM of this fraction is 8. The LCM of this fraction is 8. 8 divided by 8 is 1. 1 times 3, that will give us 3. 8 divided by 2 is 4. 4 times 3, that will give us 12. So here we have 15 over 8. So here 2 raised to the power 3 x over 2 is equals to 2 raised to the power 15 over 2. Here we are almost there. This is form of equation. What we usually do here, we just ignore these two here. They are necessary. What we need to do, equate the powers. So this is 3x over 2 is equals to 15 equals to 15 over 8. Okay, now because we are looking for only x, here, what we need to do, we are going to multiply both sides by the multiplicative inverse of 3 over 2. By multiplicative inverse simply means what number are we going to use. You will revise the multiplicative inverse of 3 over 2 is that you write the denominator to be the numerator and numerator to become denominator. So here we multiply both sides by 2 over 3 times 3x over 2 is equals to 2 over 3 times 15 over 8. This is 5. This is 4. So our answer will be 5 over 4. That is the value of x. Okay, so x is 5 over 4. And our question did not end there. So we should find s squared plus 2x. So we are looking for s squared plus what? 2x. S squared means 5 over 4. 5 over 4 squared plus 2 times 5 over 4. So 5 squared is 25 over 4. And 4 squared is 16. Here 2 here 1. 2 in 4 is 2. So 5 over 2. So and here is a fraction again. The LCM is 16. The LCM of this fraction is 16. What we are looking at, what we are doing here is 25 over 16 plus 5 over 2. And the LCM is 16. 16 divided by 16 is 1. 1 times 25 is 25. 16 divided by 2 is 8. 8 times 5 is 40. So if we do that, this becomes 65 over 16. So the value of 2s, value of s squared plus 2s is equal to 16 over 65 over 16. Okay. Now let's still continue. Let's look at another question. More example. Let's look at more example. Here, let's look at this question and see how we can resolve it. We have solve this. So for x, I have 9 raised to the power 2x plus 1. 9 raised to the power 2x plus 1 times 3 raised to the power x plus 1 times 3 raised to the power x plus 1 is equals to 27 raised to the power 2x minus 1. Okay. Let's look at how we can okay, minus 2. So look at this question before us. This question is a typical question based on indices, but we have seen equality sign here. So we use the same approach here. But here, you know, this is 9, this is 3, this is 27. So they have a common prime number here that we can express them. So like 9 is 3 square. Okay, this 3 square, we have a power here, 2x plus 1. So we open bracket, it will be 2x plus 1. We close the bracket, times 3 raised to the power x plus 1. This 27 is 3 raised to the power 3. 3 raised to the power 3. I will have a power here before, which is 2x minus 2. Close the brackets. So the next thing is, let's open this bracket with this power here. 2 times 2x this is 3 raised to power 4x, 2 times 1, that will give us 2, times 3 raised to power x plus 1 is equal to, on the right hand side we have a 3 raised to power, you open the bracket here, 3 times 2x, that will give us 6x, then 3 times minus 2, that will give us minus 6 as well. Here we need to perform this operation before we proceed. So this is multiplication and the base are the same, so we need to add powers. So here we take the base as 1, here we have a 4x plus 2 plus x plus 1 is equal to 3 raised to power 6x minus 6. Here we don't have anything to do with this. We quit only the powers. This becomes 4x. Okay, let's just do it. 4x plus x, that will give us 5x. 2 plus 1, that will give us 3. On the right hand side, we have 6x minus 6. So this is now a linear equations. We need to collect like terms here. Here, this is 5x. We move this way. Y minus 6 will come this way. So we collect what? Collect like terms. So here, this is bigger, this is smaller. So let the smaller one move this way. Here, plus 3 and minus 6. This one is smaller. Let the smaller one come here. So this will become 3 plus 6. This is plus 5x, as it's going this way, become minus 6x minus 5x. Here this will become 9, and x, 6x minus 5x is just x. So we say therefore s is equal to 9. Alright? Okay, it's all we can take on this application, and in our next class we'll see, going to look at another aspect of indices. We call it indicial equations, where indices, question in form of indices, we can resolve it and by using quadratic equation. But in this class, this is where we stop. I'll see you in our next virtual class. Have a nice time.